All right, so we're getting into the meat of the new stuff for today, which is uninhibited growth formula, and then there's a half-life formula. And uninhibited growth is where something is going to grow without any limitations. I was talking to the class about how that doesn't happen much in the real world. Usually things run out of food or there's space issues or whatever. So this is always your start, and this is always your end. E is just a number, so what's left? K and T. And what's T? Time. So then the only thing you really don't understand is K. That's the constant that actually tells you whether these are going to grow really fast or grow slow. But since this is called uninhibited growth, that implies the K is going to help you tell how fast the thing's going to grow. Okay? And that depends on the situation, totally. You know, obviously rabbits multiply at a certain rate. You know, a snake population in the Everglades that we were talking about could grow at a certain rate. The Ks can depend on the situation. All right, so here's how we would do this one. They gave us 14 megabunnies in year 0. So that's this. That's 14. Everybody put in a 14 right there. Then they say in year 3, what did that just do? T is 3. You have 44 bunnies. Did that change our starting amount? No, it changed the ending amount. The ending amount is now 44. Solve for K. You should be able to do it with some of the strategies that we've been talking about. One of them that on the 6 strategies is get the clump alone. We need to get this clump right here, the thing that's got the exponent in it, that needs to get alone. So go ahead and you can simplify it down, but I understand you don't have a calculator. Your answer will look like something like this. ln of 23 thirds divided by 6, or 1/6 ln of 23 thirds. So I get it's not a nice clean answer like 4. I'll pause while you give that a try. Okay, so you should have had 44 divided by 14, because we divided both sides by 14, to get the clump alone, equals e to the k times 3. And then to get that rewritten, I'd like to simplify this a little bit first. That's going to be 22 over 7. Now I'm going to rewrite it as a log. Log base e, also known as ln, of the other side, 22/7. Come back, equals 3k. Then I'm going to get rid of the 3 by putting a 1/3 in front. We're dividing the whole thing by 3. There you go. There's k. But you're not done. How many got that far? Raise your hand if you got that far. Good. But you're not done because the follow-up question asked about what if we make time 8? Well, then I got to go back to the original equation and put in the stuff I know. And this is really important. Everybody write this with me. I don't know how many ending bunnies we have. So it's n of t. I do know the starting bunnies, which is 14. I do know e is still e. I know k now. That's important. So k goes as a power up here, 1/3 ln of 22/7. And then I times it by t. But we know t. It told us. The new time they want us to use is 8. Sometimes they just ask you for an equation. That's your equation. Sometimes they ask you to use an equation like this to find out a new number, like 8. And you'd put the 8 right here. And that one you'd need a calculator to get. At first I thought it would simplify down nicely, and that's what I did wrong in the other video that I am replacing with this one, is I thought it simplified down really cool, but I'm not going to show you that whole thing because it was a bad waste of a few minutes. So anyway, this is it. Once you put an 8 in for t, you just put it into a calculator if you needed the decimal. But you might say, but wait, since we don't have calculators in the test, what would we do? You'd leave the answer just like that. Yes? Yeah, that's what I thought too. Couldn't you go that since that has a base e, shouldn't the answer just be 22/7? But it's 22/7 to the 1/3, which doesn't work out real nice because the third root of 22/7 is still icky. And so yeah, we can simplify it a little bit, but you need a calculator to finish it. What I did wrong was, yeah, no, I don't even want to go there. It'll take too long. Okay, so radioactive decay. It is pretty much the same equation. Let's look at it. Doesn't it look pretty much the same? Got a place for a start, got a place for the end, and it is the same, except that with radioactive decay, you kind of have to figure this number out yourself. Think about it. If half-life is what we're talking about, if you start with 20 and then you're doing a half-life problem, what's the end number? 10. Do you get how you don't have to be told this number? If we start with 20, you know you end with 10 if it's half-life. See what I'm saying? They don't have to tell you as much. All right, so let's actually just jump right into setting this one up. So I'm going to save some time. It's all about iodine. And then they say the half-life is 8 days. That seems important. Where do you think that's going to go? Time times 8. So I'm going to put this down here and replace it with things I know. Yeah, and I just figured out the time was 8, so I'm putting an 8 there. 5 grams is present initially. Ooh, I know that. That's a starting thing. That's amount 0. That's the starting initial amount is 5. Ooh, I'm pretty close. I just need to know that A of t, and I just talked to you about it a second ago. How do you find A of t? You can do it in your head. 2.5. Because it's got to be half at the end. And then the first step you do is to divide by 5, and you'll see the half-life show up again, because that turns into a half. Some people ask me, can I just always do a half-life problem by saying 1/2 equals? I wouldn't recommend it, because what if we do the problem in a different way so that we aren't telling you these numbers, we're instead telling you like k and asking you to figure them out. So I don't recommend you always start with a half here. Just let the problem be solved the normal way. Set it up with start goes here, end goes here, and yeah, if it's a normal one, when you divide, you'll see the half show up right here. Okay, so then that's 1/2 equals e to the k times 8, and then from here, this should be easy for you, I hope anyway. So you're trying to get the k alone, so you do a rewrite, ln log base e of a half is equal to 8k, and I'm going to just kind of jump right to making this a k by taking 1/8 on each side. And there you go, I found k. I found the constant. But look at the question. The question doesn't say what's k. It says find a function which gives the amount of iodine t days later. That implies they want the t in the problem. Well, they want me to have a t in the answer. Fine, here's my equation. A of t is A of 0 e k t. Why isn't that okay? Because I know some stuff now. I know k. That k up there has to be replaced with this new thing. That's k. So I'd write, I know it's a little messy, but 1/8 ln a half times t. And now, do I know my initial starting amount? Yeah, I know my starting amount was 5 grams in this problem, so I can put that here. So I can get rid of that and put a 5. That's an equation that puts in everything we know, but leaves the time a variable. That way, if we want later, they can tell us, okay, now use it to find time is 24 days. How much is left? Anyway, so that's writing an equation. It's just going back to the original and then making sure that you include, now that we know what k is, that you put it right there for k. All right, so that's writing a really complicated equation for half-life that's all ready to give you an answer. If you put in a t, you can pop out the answer of how much of this stuff is left in this much time. Sir? it can be a half, but what if instead they don't want to know about half? What if they want to know when is 80% of it gone? See what I'm saying? So you don't want to just assume they're going to ask you about half, because that is pretty easy. When is half of it gone? Well, you just look at the half-life and say, well, in 8 days. But when is 80% gone? Well, then you'd have to go, okay, it started with 5. I got to figure out what 80% of 5 is, which is actually 4. And I could put a 4 here. So if they want 80%, you do that. If they want, when is only 10% of it left? Well, 10% of 5 is 0.5. And I put a 0.5 there. And then I could solve for t. How long, how much time. All right. So let's look at your homework assignment together. And no, we're not quite ready to just jump into the assignment because we got a little bit of practice problems that we're going to do together in class that are kind of unusual. We've placed them around the building. I'm going to be out roaming, sort of like a scavenger hunt. It's not quite that cool. I'm going to upgrade it next year, but to start with, you're going to be out in the hallway in groups and answering some questions. I'll show you more about that later. But I'm just trying to say, I need you to get to this spot so I can tell you what your homework is, and then we're going to go do that little project. It's not a project, and it's easy, and you just get to work with your friends, and I'll tell you the answers at the end of the hour. So it's not like anything like a lab, super long thing. It's just quick. All right, so here we go. This one, I know it seems like so many words, but basically, here's the info you need. Initial amount's 50, half-life is 5.27. You're going to stick it into the formula and find K first. Once you found K, you write that equation that has a T in it. Leave T in your equation. All right, so I'll help you get started. So first step is it's always the end equals the start times e to the kt. My end, I don't know yet. My start is 50, and my time is 5.27. And this one's got a trick because it is a half-life question. What can I put for the end? Half of 50. 25. There. Now I can solve for k. That's this part. Once you've got your k done, then you can write the equation, which will be the same equation, except you know this, which is your starting amount, 50, and you know k, which is going to probably be log base e, blah, blah, blah. You'll have to find that right here. Then they're going to ask you to find out that 90% thing. So that's where you take your 50, you find 90% of it, which would be 45. And the 45 is the end value that would go there. All right. Moving on. I'm going to give you only a couple of these. This is the second one that you have to do. This one you can skip. Skip the gross domestic product question. Actually, a couple in this case means 3. I'm going to give everybody else 3. I got to give you 3. This number 23 is also assigned. And then you can skip the last one. So it's basically 3 of those kind of growth questions. And that normally, literally, that should be 15 minutes. And if I stopped right now, we could have it all done in class. But you'd miss out on this amazing activity. All right, I'm going to stop right here.